Okay, for 4.4, number 5, we're doing concavity. That's a second derivative characteristic. So you need the second derivative. Okay, so once you find the second derivative, you need to find the critical points. To find the critical points, I have to put this in a factored form. Let's see what goes into both of these the best. 6x. Okay, just like critical numbers, critical points occur the same way. When a numerator is equal to 0 or denominator is equal to 0. You guys saw that in the lecture, so I'll just write it out. So the critical point here will be when x is 0. That refers to when this equals to 0, or when this 3/2. That's when this piece equals 0. So the procedure is the same. The conclusion, like what you conclude, is different. This is all real numbers. It's a polynomial, so I don't have to worry about any domain restrictions. Again, the procedure is the same. So once you get it from 4.3, you have it. You just have to make the new conclusions because it's a second derivative, and the second derivative refers to concavity and inflection. All right, so test values, whatever you want to pick. Okay, so I'm going to plug it into the second derivative. So I like to do it the factored form. That's not everybody. That's just me. So if that's not you, you can plug it into this line or this line. This line to me is faster. So a negative here, that would make a negative. A negative 2 times this minus that is -5. So it's a negative times a negative, which is positive. Okay, this means the second derivative is positive. That means it's concave up. All right, if I plug in a 1 into here, the first one is positive. A 1 into here, this is negative. So this times this is negative. This is negative. Second derivative is negative. That's concave down. All right, I'm plugging in a 2. That's positive. That's going to be positive. So positive times a positive is positive. That's concave up. Okay, so let me make sure I'm answering the way they want it. We just got to do concavity. Okay, so I'm just going to write it out in words. So I found the critical points. I'm just going to write down what the concavity is now. You're concave up on -infinity to 0 and 3/2 to infinity, and you're concave down. This is referring to the original function, right? This talks about what the original function is doing. And the original function is concave down on 0 to 3/2. Okay, that's it. That's all they're asking. Catch you. Bye-bye.